Hi, my name is Dan, and this video is one in a series of videos that I'm doing on developing multiplexers in digital electronics using a simulator, which is part of a larger suite of videos that I'm doing, which take you or me or us from the concept of basic digital logic gates all the way through building them up to create a simple 4-bit CPU. Simulated, of course. And the simulation software I'm using is DigitalWorks, which you can see on the screen right now. In the description below, there will be a link to where you can get this. It's free software. I encourage you to play along with me and make the software as we go along. And there's also in the description below a roadmap of where we're going in terms of developing this CPU. This suite of videos, as I said earlier, is about multiplexers. Um, and so far we've developed a two-way 1-bit multiplexer, a two-way 4-bit multiplexer, a four-way 1-bit multiplexer. And in this video, we're going to create a 16-way 1-bit multiplexer. Um, and in case you haven't seen them, multiplexers are devices which allow you to take input signals or input binary numbers, in this case 1-bit numbers, um, and choose which of those inputs is sent to the output. And so there's, as well as the inputs, there's also a control signal, and that control is a binary number which chooses which of the inputs is routed to the output. Um, and there's all sorts of different combinations and ways of putting these things together. This one is the biggest that we're going to make in this set of videos as a 16-way, so this means it needs a 4-bit binary control input. So let's crack on with that. And there are various elements that we're going to need. So we're going to need a 4-bit decoder. We happen to have one here that we've created in an earlier video. So I'm going to pull that in and rotate that so that it's... no, I'm not. I'm going to leave it that way up. And then we're going to have 4 distinct... 16 discrete 1-bit inputs, but I'll wire them up in a little bit. And they're going to be wired up to AND gates. So the normal 3 components that you need to create a multiplexer are a decoder, and you can either hardwire the gates that you need for that, or in this case we're using one that we've already created. A series of AND gates, which is one for each of the inputs that you've got. So one side of that will come from the decoder, the other side will come straight from the input, which will then allow us to pick which input actually comes through, and then aggregate the whole lot together by using either one or more OR gates. And in this case, we're going to need several OR gates because we haven't got a 16 input OR gate. We've only got maximum of 4 input. So what am I going to do? I'm going to add a tag to this. I'm going to use copying and pasting to kind of multiply up this. But that's going to be our first input. This says output from the decoder. So we're going to go 0 at the left to 15 at the right hand end. And the reason for sticking the tag on there is because I can neatly duplicate these. That's twice. 4 times. Control C, Control V. That should be 8 on it finally. 16. Let's move all those along a little bit. Okay. And I'm going to need 4 inputs for our control number. 3. Well, I'm not doing the wiring yet because that's more of a tedious job. let's put some annotations in there. 10, Control 3. And having the annotations helps us keep it straight when we actually connect this up to the template later. That's going to need that, and we're going to need some 4 input OR gates. And we're actually going to need 5 of these, because we're going to take 4 from there, 4 from about there, next sets of 4 each, and then we're going to have one last one at the bottom to aggregate together into a final tag, which will be the output. Okay. So hopefully you can see where the wiring is going to need to go. I am now going to play you some music and fast forward whilst I actually do the wiring. If you're creating this yourself, and I encourage you to, then please go on with it. Okay, there we go, all wired up. I hope we've got our 4 control inputs at the top. We've got our 16 1-bit inputs here across in a line that we're going to use, and just checking according to this output, there's 0 at that end and 15 at that end. And checking the order of this binary number, the control is most significant bit at that end, least significant bit at that end. And finally, we've got an output here. So we need to create a template for this as well. And I'm a little bit fed up with this template and the fact that we've got a little extra bit on there. So I'm going to actually get rid of everything here and start again. It's going to need to be quite wide because we've got going to have 16 inputs. And again, we'll do it from top to bottom. So that's better than it was. Let's try that down. So first of all, saying what it is, it's MUX and it's 16Y 1-bit. And we're going to need 16 inputs, so 1 output, and then 4 for the control. Let's do the control first. 1, 2, 3. Come on, why not 4? There, yes, they'll do. And just going to do an annotation for that. So it's control 3 to 0, as long as I rotate it that way so that 3 is at the top. And so I'm going to do a doubling up thing with inputs. So using Control and C, get them quite close together. Might need them closer than that, I should say. Or I'll just make it nice and wide. It's going to need to be quite wide, isn't it? There's always a compromise between how close you put these things together and how big your template is in terms of it taking up space and being relatively easy to wire up. Okay. With that text to make it a bit more central. Put another one in. So this is inputs. No, let's get this the right way around. We're going 0 at the left hand end. to 15 at the right hand then. And we're going to have a single output. So let's annotate that. So as always, we're going to need to be careful how we connect up the tags in the main circuit with the pins on the template. But there's quite a few to do, and so I will play your music as we fast forward through this process. Right, there we go. Don't you sometimes wish in real life that you could fast forward some of the boring things, boring lectures or traveling on a bus or something like that, and just stick some music on and go at 5 times speed. Anyway, that's the wiring up of the template done, and we're going to save this. So what is it? It's a 16Y 1-bit multiplexer, and if we wanted a 4-bit 16Y multiplexer, it would be fairly straightforward to do this. It would just be a lot of wiring because we'd just use 4 of these 1-bit 16-way multiplexers connected together in the same way we did a couple of videos ago when we did a 4-bit 2-way multiplexer. So what I'm going to do now is, as always, or nearly always, I'm going to create another circuit just to test this. So I'm going to drag it in. Thankfully, this is probably not quite so much wiring, but there's still a reasonable amount of wiring to do. We've got some inputs to stick on, and the control inputs, and a LED for the output. So once again, rather than me try and talk through this whole process, I'm going to stick the music back on and fast forward. There we go. So time to get this tested. Let's click the simulation, get some interaction going. So at the moment our control is 0, 0, 0, and so our output should be dependent on this far left one. Yes, that's working now. Just quickly check along the line a few of the others. Make sure they're not interfering. No. So we should be able to pick an input. This one's been raised up slightly. That was accidentally. But let's work out which one it is. 0, 1, 2, 3, 4, 5, 6, 7. So I'm going to choose the 7th input. The binary number for 7 is 0, 1, 1, 1. So hopefully that number will mean that our output is now linked to this input. You see there's a bit of a delay sometimes in the simulation. Not to be worried about too much. I'm just checking that these random pins aren't connected. Let's do a last check at the far end. So if I'll check our 15 is connected, there we go. Takes a second or two to think about it. Not quite a second or two. Okay, so as I said before, if you want to more than 1 bit, you just chain these things together. The next video in this short series, I'm going to talk about a way to avoid having too many multiplexers of too big a complexity in your digital circuits. And that's the thing called the bus. But that's it from me for now.